Hello, everyone. Welcome at our core protocol sync. There has been a lot of activity recently in development, so we'll share all of that and plans for the nearest future. And what do you want to start today?
Yeah. Okay. On the protocol side, again, not a lot on my end this week because most of the last week was focused mostly on finishing up the things on Feats palette and also a bit more research into parachain validation. So no updates there. So if you have any questions, but I'm happy to answer.
Okay. Are you planning to cover that on the integrations call tomorrow
Yeah.
instead?
Yeah.
Okay.
Okay, anything is coming up in the nearest future?
Near future as well, I think it's going to be most likely integrations once we have the parachain validation spec figured out and see if it's ready to be progressed there. Uh, Again, not a lot to be discussed on the protocol side on my end unless I can pick up some pieces there along with you, Shank. If not, then nothing much.
Okay, that's fine. Lucheng then?
Okay, sure. Let me share my screen. Okay, here's my screen.
Yeah.
Okay, great. So during the last week, there are basically two notable changes. One is about the runtime validation for the submitted execution receipt. This one, okay. So there are a few points we have discussed before, like we need to ensure the block that they submitted receipt should point to a block which is part of the history. So and we also need to handle the out of order issue, which is caused by the network delay. We should cache some invalid future receipts in the transaction pool, which is done similar to the nonce mechanism. So, and another point is we need to ensure the parent receipt has been included. And we also need to revert the execution chain. That basically means to remove the invalid receipts after the one that was reported by the verified fraud proof. So basically, those points should be covered. And the lessons in this PR is that regarding this point, I was using an unnecessarily much more complex approach. I wasn't aware of the system palette is already stored a map of the block number to the block hash. So I used the host function, which is the last resort we should leverage after some discussion with Neta. Yeah, I totally agree with that. Yeah, so that is the digest for this PR. Any questions, comments?
No?
So, okay, well, so next one. The another one is basically about this broadcast when do we broadcast the execution receipts previously we simply when the executor major sync is finished, we simply broadcast the receipts against the tape of the execution chain. So as discussed, we should start to broadcast the last seen receipt on the primary chain, instead of this tape of the primary chain. So I think it's more straightforward to see the final results. So we have this check if this executor node is in major sync or not. So if not, we'll check if the current best execution chain on the primary chain. If it's in the ideal case. The ideal case is the primary number, the primary chain block should include the previous, the receipts for the previous block, which is just the best consensus chain number should equal to the best execution chain number plus 1. So that basically means no receipts was missing. Otherwise, we should check some receipts for some previous blocks was missing. We should do handle that. Okay, so that is basically we should to send the receipts from the last seen block of the last seen receipts on the primary chain. So basically the main changes in this PR, I believe. So any questions?
No, everything is clear for everyone.
Okay. So I do have some open questions. Okay. About the next step.
Can you zoom in just a little bit on your screen, Lucian?
Okay. Is it enough? Or
Yes,
better?
thank you.
Okay. So I have a problem about this expect flow proof within next X blocks. I think the X here means the receipt pruning depth or the receipt challenge period at that block. Is that right?
Yeah, I think
Yes.
it is the same as pruning depth.
Okay, great. So, okay. Okay, another thing is, in the case that we don't store all the receipts on the executor side, we also prune the oldest one once the executor the receipts on the executor reaches the capacity of the receipts cache. So if the receipts has been pruned, but we need that to report a fault proof, we basically need to re-execute this block and regenerate the receipts.
Why
That
would you need
means
that if it's already pruned? What is the use case?
Because the receipt was missing on the primary chain. It's never has been included on the primary chain. We should submit.
Oh, I see. Okay. So okay, I think you shouldn't prune. So the pruning depth should be relevant relatively to the number the newest ER that is included on the primary chain in that case.
Okay, so you are suggesting we modify the pruning mechanism. Okay, makes sense.
I think so. Otherwise, it might be the case that like all of the executors that were elected, they just didn't submit any ERs, and like the chain was moving forward, and then it's your turn, but there are like 3,000 ERs missing.
So I was also thought like perhaps we can like re-execute that block, but that requires we do not delete the block body. So,
yeah.
Okay.
I think initially, probably the very first version will be archival node of the executor, and full node of executor will be another upgrade later down the road. So you should theoretically be able to re-execute the block, but yeah, you should probably just keep it. Keep ER.
So yeah, I think it also makes sense to modify the pruning mechanism. Yeah, I'll choose this one.
Hey, Cheng.
Okay.
Can
Yeah.
you back up? We're in the post MVP state. Can we just back up to the like the MVP tasks? Like what is left for that right now?
Okay, all of those has been checked. I just didn't check that. All of them has been done, has been
Looks
finished.
much better.
Even the two that you haven't checked?
That was an alternative.
Okay, so that's not so what is that?
Okay. That's fine.
Okay. Now what is the, if you can scroll back up to the box that you didn't check, what is that?
This one is an alternative.
It was about dependencies between ERs. If it didn't work, there was another alternative to use, but it works. So.
Oh, okay, got it. Okay, so not that if it fails, but just if we can't implement it.
Yeah.
Yeah.
Okay, got it. Okay, so we have the MVP of decoupled execution ready.
Yeah. So that is like actually I'm going to talk about.
Okay.
Okay. So last time we have talked about this like we call XNet, right? So I have created a separate branch for this XNet, and I have tested it locally. Seems to be fine so far. So, but I would like to know the purpose of the XNet and like, what do we expect from it? What functions should be tested? And is it going to be like totally internal or private or something? Yeah, I would like to.
The purpose of XNet is to take the leap from it works on my machine to it works on the live network with multiple users, which in my experience rarely works the first time. So that's the main purpose, is to test it in a live setting. Does that make sense?
But it has to be a fresh new network, a fresh new test net.
Yes.
Okay, so
Okay.
yeah, we can probably talk about that after recording.
Okay.
Uh,
I have an idea how we can do it.
Okay, sure. So
yeah, the expectation is that we will launch a, we're going to have like FarmNet, RelayNet, XNet. We'll have multiple networks, and that we will get people from the team or testers from the community running nodes on there. There will only be one executor. There will be multiple farmers. And once we have that live network, then we want to run all these tests as well. Like, what does it work in the happy path? Does it work in the case where there is fraud? Submit like a fraudulent execution receipt, at some block. Do we have a second executor on the network that produces the fraud proof? Does the invalid execution receipt get scrubbed out of the chain? Do we continue with a new execution receipt after the fact? Like, does the system work as expected in the cases that we have handled? Have we tested that on a live network with actual farmers on the public internet? We're not going to try to restrict permission. It doesn't need to be a private network. There's just no incentives. And we're just going to have to ask people to join it. Eventually, we will merge this into FarmNet, but we want to test it a little bit before we put it out with, lots and lots of users.
Okay, we can talk about all of the recording. So that's everything on my side.
Okay, that seems like a lot of progress. Thank you.
Yeah, great job, Li Cheng. Really, really excited to see this as a huge milestone. Just need to get it deployed and get it live.
Yeah. Ivan, you're next.
Yeah, sure. Let me just share my screen. So here it is. So basically, last week I was working on like some minor issues, and mostly I was working on the adding the bench command and some stuff around that. So there was a bug reported by a user that he hit the limit of open files on Linux. So yeah, I just created a PR which would increase the file limit. Yeah, from soft to hard. Yeah, nothing fancy here. And like the rest of those PRs, they are related to adding the bench command. Yeah. So basically, I started with the some simple PR, which would just create and add the bench command, which would basically start the mocking archival process in the background. So basically, now users can users can just ask the bench command. They can just run the bench command and provide the plot size which they want to have. They want to they can also provide how much information do they actually want to write to the disk. Like for example, for now we can only write nothing or everything. Nothing here states that we will use some mock file for the plot. Yeah, so that we could test some surroundings of the farmer. Yeah, and we could also restrict the max plot size here. And user also must provide the amount of data which he wants to plot during the benchmarking. Yeah, and basically within that we just start the.
I just have a quick question. Why is that number different from the plot size?
From the plot size, it is different because we might want to overwrite several times the plot. For example,
Right.
we have.
Okay, makes sense.
Yeah, let me just.
I have a question too. When you say user, do you mean we're expecting users to bench, or you just mean that when we bench it internally?
I think it's fine both ways. Like we can use it internally, and maybe we could also use it via GUI at some moment, just to see the speed of the disk.
I guess whoever calls the command is the user.
Yeah, right.
I'm just trying to, right, but that determines somewhat the design of this thing, who the intended end user is. And at this stage, it's really an internal testing tool. You are the user, Yvonne, or Ozgen or Justin is the user.
Yeah.
So I just want to make sure that we're not overcomplicating this design so that we can create this really great experience for people to bench their hard drives, which is an eventual goal, but trying to just stick to something minimal that we can test right now so that we can at least debug it internally.
Yeah, totally. Right now it's I already pointed out some thoughts that we could do towards the benchmarking real users hard drives and everything. Yeah, we could probably calculate how much data we need to write during the benchmarking. Yeah, but right now it is supplied via CLI. So yeah, maybe later, I guess. At least we can leave it right now as a developer tool. Yeah. And yeah, I wanted to show that basically we just start the benchmarking, and benchmarking internally, like it just tries to mock like it basically disables farming for the for the farmer itself, so that we could only like archive some mocking pieces which we create in the background, which is created here. We just basically create some random segments of the size of the like here it is 1000, but it's actually not correct. I fixed it in some future PRs. It's supposed to be 256. And we just
Sorry.
create.
Quick question. You said we disable farming. I thought that in the current plotting implementation, we didn't start farming until the plotting was done already.
No. I mean we don't even have the farming instance for the benchmarking. So basically, I added the flag for the like multi-farming. For the multi-farming, which would like signal whether we want to start farming or not. And we totally disable it for the benchmarking.
Shouldn't actually make a big difference or like difference at all unless there are challenges, because unless there are challenges, it shouldn't do really anything.
Right. Yeah. And I guess that's it for this kind of workflow. It's just an initial setup for future work for the benchmarking. As like recalling the yesterday discussion related to the printing of the throughput. I actually open PR with those kind of info, with this kind of info. So here it is. So for example, like the developer would start the CLI with those kind of flags, and that would print some info like this. So for example, here's plot size is 1 GB, and we want to write.
Can you zoom in a little bit, Ivan?
Yeah, sure. So basically it would print that it finished benchmarking. This is how much data is allocated for farming. Here we take like 80% of this 1 GB. So for the actual plot. So that's why the total size is something around 80%. And the actual space pledged here is just the this size of all of the plots, basically summed up. And here it is around like 94-95%. And basically that means that it's like 5.5% overhead. And here the average throughput on my hard drive is around like 94 megabytes per second. And it took like 20 seconds for me. Nothing.
Ivan, does that capture the, like, is that assuming that we have a 100 gigabyte history here, or is it less than that?
No. It actually it uses like I'm not sure whether it's like okay to say like to do analogy with the history here, as like we basically there are two variables here. One of which is like how much space we want to use. Like here it is 1 GB. Another variable is like you're actually right. The amount of pieces which we want to write. So basically that means that the history itself is around 2 GB here. I didn't test it like for 100 GB yet, but I could do that like today and print some put some info in the engineering chat for that.
Yeah, I guess what I'm trying to say is if like the piece, like if it's 2 gigabytes of history, but the plots are only filled up like 2%, then are these
It's not
numbers?
2%. Like the whole plot you have is 1 GB.
Yeah.
So it will fill the plot of 1 gigabyte and then we'll override it.
So that means here that we override like 2 times the actual plot.
Okay, so this is just a canned example. This is not like a real. This is not in any way realistic to what it's going to be. This is just okay. I got it.
Yeah.
So
Yeah.
no, the output is correct. This is great. Thank you. This is what I was looking for. I would just really like to see this now for like 1 terabytes with, 100 gigabyte history size, and then see what that looks like. That's kind of really at the end of the day what matters.
Yeah, but yeah, I could do that totally. Yeah, the thing is, like the actual plotting speed is kind of faster right now after the after VSPR. Yeah, I also like said something about that like yesterday. The thing is, we had a constant for the caching purposes of the index hash to offset a database for the farmer for the plot. So and it's actually like slow path when we exceed the plot size and start like evicting pieces from that. We start looking for the max distance like piece, and that basically constant. It stays the cache for the max distance keys in this kind of database, and it's actually slow path. And basically, yeah, we increased the cache from 100 to 8,000, and it basically the thing is the whole speed of the whole farmer was around like 4 or 5 times faster. Yeah, here are some graphs basically related to the cache size. Yeah, basically here's some info which I plotted. Sorry. The thing is, for the like 100, it's supposed to be like something here. It's around like 100 nanoseconds. Yeah, which is very slow. And at some moment of time, we basically stop seeing the speed up of like increasing the cache. Yeah. I also have like
Sorry,
another.
what are we caching? What is the max distance?
Could you repeat, please?
What are we caching here? I think we've gotten out of sync with my understanding of the implementation versus the protocol.
Oh, yeah, right. But the thing is, we are caching the max distance keys. So basically, at a moment of time when we hit the limit of the plot size, we will start like evicting like furthest pieces. So this cache, it actually it is used for like finding the furthest pieces from our identity.
So this is only for the like updating of the plot over time, not for initial plotting.
Yeah,
no.
basically store some number of data from both ends. So when we need to evict something, we can do it quickly without reaching to actual disk.
Right. Okay.
That's only when the plot is full.
Right. Okay. Is that a problem right now that is really slow to update that?
Yeah, totally.
Okay.
But that's not a problem because we have a cache. So
yeah. After we increased cache, I actually I discovered that the thing is yeah. Let me just show
how did that problem present itself?
Yeah. Let me just find the.
Just takes a long time to evict an old piece and write a new one.
Okay.
That process of like searching what is the latest, the furthest one, deleting it, writing new on top of it, updating this, just takes a long time.
Okay.
Yeah.
This is just an internal testing that we've done.
Yeah. I just found the pull request, which was merged like 2-3 weeks ago. So the thing is, at the moment before the merging of VSPR, we had some flame graph like this.
Right.
Let me just.
No, I think I understand now. Yeah, it makes sense. So I guess what I'm getting at is that we're kind of optimizing the endpoint, but we still haven't completely optimized the plotting process itself. Like we know
This is the plotting process.
Yeah, yeah.
that's only as like once the plot is full. Like we have to fill up the
Sure,
plot
yeah.
before we can start evicting pieces out of the plot, right?
Yeah.
And we still haven't really gotten to the point where we can even fill up like a full disk, like, or we're not really sure how long that takes, or like what the bottleneck is there. So we're kind of like 2 steps ahead in terms of the optimization from where it feels like we need to be.
Well, but we will have the DSN sync, and that will change everything anyway. Like we just don't have enough input right now to feed into like encoding on GPU and to write big batches. Just like node is not syncing fast enough to produce that much input.
When we sync from the node, or
Yeah,
right now.
once we have DSN, we can pull much more data.
Okay. So right now, the bottleneck on plotting is syncing the node.
Syncing the node and then encoding.
Yeah.
And we are doing encoding on CPU. We are not using GPU.
The
yet.
encoding is always taking more time than syncing? Or do we not know?
I think the syncing is a bottleneck actually. Like the second like longest thing is encoding, but yeah, but the first
I
one is
think-
syncing.
Yeah, I can confirm. Like I tried with double or triple size of a plot, and it was the same amount for GPU, sorry, desktop application. And if syncing was not the bottleneck, the time would increase for twice or thrice the size of the plot.
Okay.
So syncing is the bottleneck right now.
Yeah.
And
Yep.
do we like, well, okay, I guess that doesn't matter. Never mind. Okay, so I guess I'm just trying to step back here and think about the big picture. So if syncing is the bottleneck, should we retask around changing the sync mechanism before we put any effort into optimizing the pruning of the plot? Nazar?
Well, but if you have a problem with pruning of the plot, it needs to be fixed sooner or later anyway. If you are seeding the history to 100 gigabytes, everyone will have a full plot right away. So they'll be wasting a lot of disk access.
I see that
if
they
you don't
both need to
optimize
be done, but for sure, I mean, everything needs to be done at the end of the day. But it's kind of like we're putting the cart before the horse in terms of like, we're solving a problem that doesn't exist because we're not really sure that people can plot the full history because it just takes so long. Right
Well,
now,
they can. Like,
Yeah.
they surely can.
well, okay, but how long does it take at a 100 gigabyte seeded history size to plot 1 terabyte?
We'll benchmark it.
Yeah,
Have we
but
benchmarked that yet?
yeah, the thing is, like beforehand, I actually hit the exact limit of the plot size. Like the moment when we have like several plots, there is like one plot which is the last, which is actually like the partial one. We have like, for example, 5 full plots and 1 partial one, which is like 50 gigabytes or something. Yeah, and the thing is, when we hit the limit of the last one, the plotting of the last one will become the bottleneck, and I actually hit it during the like local testing.
But I thought we just disabled that until we optimized that process. So we only did like 9 plots instead of 10, like 9 full plots and then not a partial
We
plot.
didn't change it.
Okay.
But the thing is, we don't have to change it like at all right now. The thing is, like I'm showing some stats right now. Yeah, the thing is, there are 3 things here. Yeah, there are stats for the scenario when we have this cache set to like 8,000 as it is set right now. The piece eviction, it actually takes like yeah, the scale here is a bit odd, but yeah, not piece eviction itself, but writing, yeah, writing the plot is around like 1.2 milliseconds, which takes like 12% of the whole process of writing the segment, of archiving the segment. Yeah, beforehand, when we had the cache set to 100, we actually spent like 80% of our time in the writing to the plot, like 16%.
And if it didn't have a cache, it was even worse than that.
Yeah, it was like 5 or 6 times.
Just
slower.
didn't work, basically.
Yeah, at all. Yeah. And there are actually some stats like without piece eviction. Yeah, here writing to plot takes like 11% of the time. Yeah, but the thing is, the variance here is a bit is very low, like in comparison to the to this scenario. Yeah, because we sometimes need to refill the cache. But overall, I think like we were really close to the to the ideal scenario, to our fast path.
Okay. So we can now create the last partial plot?
Yeah, I believe yes. Yeah.
Have we tested that?
No, not yet.
Okay.
Yeah, it was merged like yesterday or like yeah.
Well, this is testing, so
Yeah, this is testing.
But we haven't tested the full workflow end to end to
Mm,
confirm that we can create this full plot.
I actually tested it on the yeah on like 10 on the plot size of 1 gigabyte and writing the history size of 10 gigabytes. Yeah, so it's not 100 gigabytes, but still I could test that on 100 gigabyte plot today. Yeah, and update in the engineering chat.
Yeah, I mean, what we need to get to, like as soon as possible, is on a hard disk drive.
Mhm.
How long does it take to plot 1 terabyte, assuming full history? Like that's the basic benchmark that we need.
Mhm.
That's when I would say it's like tested and we're sure that it's working end to end. So it's great to like do these incremental tests to build up to that, but that's really the goal that we need to get to as soon as possible. Because as far as I know, we haven't actually plotted like a fully saturated plot at 1 terabyte yet. We haven't been able to complete that process, right?
Yeah, right.
Okay. Okay, so this is good. So we're making progress along that path, but we're still not there yet.
Yeah. Okay, I will update that like in some recent days. Yeah. Yeah, but apart from that, I was also working on the benchmarking command. We discussed it with Nazar a bit after like I implemented some Scratch version of that. And the thing is, I decided to like remove the log crate with tracing, substitute it with tracing, and after that, use that for the for the benchmarking. Yeah, nothing very fancy here. I just substituted the log crate with tracing. Yeah, and more fancy is the last PR, which I opened like some time ago, so today. Yeah. The thing is, I added some metrics for farmer, and I also used the crate, which is called Tracing Flame. The thing is, it lets us generate fancy flame graphs like this. So basically, yeah, I will put it into the PR. Just didn't have time for that. Yeah, so that so we could basically inspect like how many time is spent like during in the encoding itself, how much time is spent in writing the pieces. Yeah, here info is a bit weird. I don't know why. Yeah, because like many time spent in waiting in the queue of the plot worker, which is weird. But still,
it's probably not weird if you have small batch size.
Okay. Okay, but still, I just want to give an idea how it would look like. So yeah, I just added some CLI option for that for
Make sure this thing doesn't introduce a lot of overhead on its own.
Yeah,
Because
it
there are
does.
some tunables, I believe, that can be tweaked.
Yeah, it actually does. Yeah, it actually does produce the overhead. Basically, we can provide like file for the tracing. Like if we don't, we just won't have this fancy thing. Yeah, and it won't produce overhead. Yeah, and the thing is, we just modify our logger for those kind of purposes. Yeah, so we basically set up the extra layer for the logger, which would extract some special info. Yeah, and print this chart. Yeah, that's it for my side. This week, I will work on finalizing both pairs, and we'll move on with the helping Azar with the DSN.
Yvonne, can you describe the current workflow you're using for producing a fresh blockchain from scratch and seeding it and then doing this plot testing?
Right now I'm just using this bench command. Yeah, for the testing.
Okay.
It works way faster than my previous setups.
Okay, but is that the same as the real environment?
It's not, because it doesn't have like farming, for example. But overall, I think like it's very close.
Okay.
I mean, it doesn't take into account the node overhead if it is using the same disk, but otherwise it should be comparable.
Yeah.
Okay, so we're basically just creating a plot. Like the farmer is just running in isolation as though there was no node, is how this is working, and it's not actually farming.
Yes.
Yeah.
Can you set the command to create 100 gigabyte plots and plot 1 terabyte?
Yeah, but that's what I thought of doing after the meeting.
Okay. Is it possible in that report that shows the plotting progress to pull some information from the system about the hard drive that is being used, or the system information, like the number of cores or the speed? Is any of that accessible?
Yeah. Yeah, I'm not sure about the hard drive info, but yeah, overall, like CPU info, like RAM info, yeah.
Okay. I'm just curious. That would be useful if.
It's like a rabbit hole to me.
Well, I'm just thinking if we are going to expose this to users, they'd have to because the plotting information is kind of meaningless without the context of the disk and the machine that they're using it with. And if we want to ask them to take screenshots of everything and then show us that, it would be easier if it just pulled the system information automatically as part of the report. Just curious, not something to work on implementing. Okay, so Yvonne, our priority right now is to test this in, going back to what I'm harping on with Lu Chang for, it's great to I ran it, the code works, it works on my machine. It's another thing, does it work in the actual setting that our users are using it, right? So it's great if we bench it and we write these benches to figure out these issues quickly. But then once we think it's working, then we really need to test it in a real setting and confirm. We don't want to push it out to production and test our code in production in that way. We want to confirm the full thing is working. So what I'd like you to focus on, your number one priority now, finish these 2 PRs, create a 1 terabyte plot using your bench command that has 100 gigabyte 100 gigabyte plots at a 1 terabyte plot size with 100 gigabytes of history. Okay. And output that report. How long does it take? Does it take 6 hours or 6 days? Hopefully it takes 6 hours, but we need to confirm that. And then once we get that, then we need to run the same thing with a node with 100 gigabytes of seeded history locally and confirm how long that takes. And I think that will take closer to 6 days right now, is my estimate. But that's really the next step that we need to get to, because I think that if we don't do that, we're going to be in for a really big surprise. Our users are going to be in for a really big surprise, and we're going to create a lot of heartache for ourselves when we launch, if we haven't done this before we push it out there. Does that make sense?
Yeah, totally makes sense. Yeah, I thought also about like doing the benchmarking. Yeah.
Okay.
All right. Ozgan, do you have anything to share this time?
No, still busy with Subspace desktop.
Okay.
Can you
Shamil,
at
do
least
you
give
have?
us as to the difference between everything we're describing and where Subspace desktop is right now in terms of what we're caught up to?
If that was to me, I missed the first part of the question, Jeremiah.
Yeah, that was to you, Ozgan. So can you at least describe the difference between the implementation of the core protocol and what features are there versus what features are in the desktop app, and when you expect those features will be in the desktop app?
Sure. Latest PRs are not reflected to the Subspace desktop. Subspace desktop is using revision from the core protocol, which is like after multi-replica became stable. So we are using multi-replica, but other than that, like this new bench stuff or any update after multi-replica is not in the Subspace desktop.
Is there a particular snapshot or version that we're caught up to right now?
Yes, we have a specific revision in the cargo toml file.
And on the 0.5 branch, you have caught up to everything else, or is that what
No,
you're talking?
no,
Only includes
what
multi-replica.
I'm talking about, 0.5.
Okay. How far behind are we in terms of, like, I don't know, weeks or number of PRs? Like, what's the gap right now?
I would be lying if I have an estimate, so I need to double check on that.
If it's last snapshot, then it's probably 2 weeks, something like that.
Yeah. Okay. So because for the runtime things, we were using the last snapshot. Okay, so it should be around 2 weeks.
Okay.
Yeah, Shamil, I just wanted to ask if you have any questions about any of this or otherwise on the protocol.
Nope.
Okay, I think I can share the screen on my side. Okay, can you see it?
Yeah, if you could just zoom in a little bit.
Okay, I'll go from 2 weeks because I haven't been on the call last week. So one thing I noticed, we were testing this testnet and testnet compiled sometimes locally, and in that case, the default behavior of the substrate was to concatenate bootstrap nodes. So whether you want or not, you will join the farmnet. And I did the change where it will actually override that behavior, and it will replace the bootstrap nodes in the chain spec with those that you specify in the CLI. It's not actually readable this way, but yeah, basically, if you specify CLI parameter with boot nodes, it will replace ones from the chain spec before starting the application. That's just for testing purposes. Then there was a big change for actually embedding our chain spec for the secondary node into primary node, such that we always have it in there, always in sync. And we can use one file when we want to start a new chain. So in the chain spec that we had before, this doesn't make a lot of sense. That's not okay. Cumulus. I'm a little bit confused. What's going on here? Should be a chain spec file. Strange. Oh yeah, so in this pull request, I just moved chain spec from the Cumulus into the primary node because we already have CLI for it in here for the most part. So just the node, like in quotes at this point, only contains like a service parts. So it's basically Cumulus service, not Cumulus node, as of this pull request. And then in the later pull request, I have embedded this secondary chain spec in the primary chain spec to have one file. So in the original chain spec that we had, there is a possibility to create chain spec extensions. And this is something that Cumulus actually uses. So in our case, in Subspace, we have execution chain spec, and it basically is a part of a regular chain spec. So when we have the JSON file, it includes both chain specs, one in the other. And that way it's just easier to use. So this is like we have two runtimes into one, and now we have two chain specs in one. Yeah, then there was a change for the Reid-Solomon ratio library. I did upstream some of the changes that were necessary to compile it on ARch64. So it wasn't necessary to use our fork anymore. So I just switched to upstream. Really nothing fancy, just removed override for this. So theoretically, it works on ARch64. There is a problem with cargo, where if you try to cross-compile it with QEMU in something like a Docker container or otherwise, it will actually eat all of your RAM and crash your system. I've tried this several times. I tried it in CI as well. Just doesn't work, and no one seems to be able to help with that. So we cannot produce ARch64 images in CI. I can probably build it on my Raspberry Pi, but that's like it is working. If someone wants to compile it, they can, but we cannot produce it automatically yet.
Did you try different compiler version?
I've tried different versions of Rust, and it doesn't seem to be dependent on the compiler. It's cargo itself that like ate 128 gigabytes of my RAM and crashed my system for compiling the project. Usually it's like 20 gigabytes is enough. So there is clearly something really, really wrong. I'm just not sure what yet.
It's probably something related to the Git because it usually happens during the like cloning the substrate.
Exactly. Yeah, it tries to pull Git repository and it just goes crazy. There's actually another issue in Cargo that talks about shallow copies. So right now it tries to download the whole repository, and it takes in CI like 15 minutes to pull the substrate repository from like start to finish. And they just need latest commit, which will take like 0.3 seconds. But the library that they are using in Rust actually like it's bindings to C library, and that C library doesn't support shallow copies. There is another library that one guy writes in Rust, but it's not feature rich enough to actually use in Cargo, so we're kind of stuck there. That would probably fix the problem as well. Okay, that is irrelevant. That was a small fix. We can go in here. Yeah, basically there were some commands which were not really necessary anymore. Like they don't make a lot of sense. For instance, in secondary chain, we had things like chain spec really doesn't make sense. We have chain spec already separately in the primary chain, which includes both checking blocks, exporting blocks, importing blocks. It's really not necessary for the secondary chain separately. And purge chain actually also doesn't make sense because we have the universal command on the primary chain, which will purge both chains at the same time. So you basically treat them as one box, whether it's one or two. So just some refactoring unification again. Again, a little bit less code than before, which is always nice to have. Then there were 3 pull requests about refactoring of Cirrus. This is like remainings of the overseer, basically. I'll probably not go through all of the pull requests, all of the changes, but the gist of it is that right now we have 2 new concepts. They were just like implementation details of Executor, but we've separated them. One is bundle processor. This is the thing that can process bundles, like execute them, kind of. And this is the thing that creates those bundles as part of the executor. So I've just like separated them into separate data structures. And then the second one, remove the overseer data structure that was still around. And instead of that, we have just a little bit of code that is actually necessary to forward some of the events. So we have this process primary block, and we have another one, I think, for executing. Yeah, so basically the whole thing that overseer was doing for us, it was following the tip of the primary chain, including forks, like when it switches branch, and it was creating bundles as a result of those events, right? So that's all we had to do, but we had a lot of like abstraction layers before that was actually possible. So by separating those 2 implementation details into separate bundle and processor, and then by unwrapping the executor or overseer, it was possible to simplify it even further. I guess it's clear that it's simpler from the amount of changes, but it's probably not a great time to go into details. But Lu Cheng has looked at it. And the last one from here was to actually get rid of the overseer file. So instead of overseer file, we have what I called Executor Worker. This is basically a background process, just a synchronous function that runs, and it has 2 parallel things happening in it. One is that the thing that handles import notifications. So every time we have a new block imported by the primary chain, we'll do some stuff like process bundles in that block. And the other thing is we will handle slot notifications. So every slot we will create new bundle. So we'll use bundle producer. And that's basically all it does. That's all we need. And this is just like moving things around here. And in the executor itself, we had a little bit of code that was doing a bunch of things. Right now, we just spawn this executor worker and basically done with it. So this is the final like state of what it is, and I think it makes sense what it actually does at this point. Any questions about that? All right. I was working on different things towards getting the voting for improved reward frequency. There were some changes that I did along the way that I submitted as separate pull requests already. There were some changes in the palette subspace and related stuff. I just noticed that the way we were handling validation and other things, it could have been simpler. And this is the similar like code structure to what will voting use. So just some like refactoring, some typos, and some changes to verification code because it will be reused later. So in verification, yeah, basically some generics are simpler. And after that,
Sorry,
yeah.
Nazar. Does anybody know what voting rewards are?
That's a very good question.
Might be worth just giving a little
Yeah,
background.
let me explain. So basically, we have a problem right now that we have, like, good problem to have. We have a lot of farmers, and all of those farmers are competing for the block reward. And since there are a lot of them, and we have just one block every 6 seconds, it takes days for them to get their first block on average. And when we'll get farmers that have way more space than others, it will be even worse. So we want to improve that frequency for farmers in general. And the idea for that is to start with a simple kind of like voting mechanism, where if you have a high enough quality of solution, you will produce a block. Otherwise, you'll produce a vote that another block will include. But we'll reward both votes and blocks. So if you have 10 votes per block, then we have 10 extra rewards to give to people. So instead of waiting 30 hours, they will wait 3 hours on average to get the reward. And the idea is that we will upgrade this voting mechanism to actual voting to improve the confirmation latency in the future. So this is like a stepping stone and like a hack before we have sharding to improve things for users.
But after we have sharding, do we continue using voting?
We will use voting for the improved confirmation latency. So instead of waiting like 100 blocks, you can wait 3 blocks and have the same security guarantees.
Okay. So it's not a temporary solution at all. So it will we will continue using
It's a
this.
stepping stone towards a different solution in the future.
It's basically the voting chains that Prism uses to speed up confirmation latency. It's just a much simpler implementation.
Yeah.
And there will always be rewards for voters. This will just only scale so far because we can only have maybe a few, I don't know, 1632 voter chains right now, but we can eventually have like 65,000 shards. So this is a stopgap just to increase the reward frequency until we have horizontal scaling.
Exactly. As I was working towards that, it turns out that we actually need to verify those proofs of replication in the runtime. And for that, we need code that actually works in the runtime, which not all of that code was actually working. So we were using this library from Filecoin project, Merkle tree. It's actually a fork of a different library. The changes that they did, they have Merkle tree, which is backed by disk optionally with different strategies. And they have actually added a whole lot of code to support that. And it was, I tried to make it noisily compatible at first. I abandoned that idea fairly quickly. And I actually switched to the other library, the original. There was an issue here that I created back in September. We basically needed 2 methods that were not available. So we can actually extract data from the proof to make it useful. Otherwise, it wasn't really useful for us because we cannot serialize it. But maintainer didn't care too much about it. So we just went with a different library. But then I went back to this, upgraded a few things, added those methods and added noisy compatibility. And it was actually merged already. And in this pull request, I just switched to this new library, which is a little bit even simpler. So there is a bit less code to care about. Still using the fork. It wasn't released this pull request, but I hope it will be soon. So we have Merkle tree library that works in the NoSCD environment, which is great. We can like generate ratio coding of segments with everything, with witness and everything, and that will work in the runtime as well. So that's one part of that. Another part is in the slot library. We had support for regular compilation, including CUDA and OpenCL. I didn't work in WASM, so I created 2 pull requests, one to introduce support and then to actually fix it and make it work. So our library is actually NoSCD compatible right now. If you disable default features, it will compile and work just fine. So that's the second step and the last one that we actually need to verify it in the runtime, which is also great. I had some compilation issues. I was thinking that might be related to Substrate. So I just went ahead and upgraded Substrate. We had to do it anyway. It was like 1 month and 2 days since the last upgrade. One of the big changes was switching from the JSON RPC to JSON RPC library. It's written differently, sounds almost the same. And that also fixes the problem that we had where sometimes when you send too much data, the connection just breaks silently. There is like no error. Like there is an error in logs, but Farmer is not aware of that. It just hangs and doesn't solve anything. So we had to do some workarounds to actually fix that. It's no longer necessary, so this is still going through CI, unfortunately, but it will merge it today. We'll get some goodies. And then there is another pull request which actually removes those workarounds on the Farmer side, so it will not ping the server, like the node anymore, to figure out if it's dead or not dead, the connection, I mean. So that will be a simplification. And finally, with all of those changes combined, we can finally have the verification logic for the block as several methods, like verifying the header and the POR and that kind of thing. We can actually have it in the primitives instead of the client. So both the client and the runtime can actually use it. That will be like, this is like the final piece for actually start verifying the votes. I have voting in the separate branch. It's not ready, so don't look at it. But I will create a pull request once it's ready. This is like this was the thing that I was lacking, and I unfortunately spent too much time figuring out why it doesn't compile. So the reason for that was I didn't have this attribute for noisestd environment. Without it, it still pulls some things and makes it break. And in one place, I had default features true, which was enabling std. And that was complaining. I just didn't notice that true false thing. So I spent like maybe half a day on this. But in the end, I converted two libraries to noisestd and made it work. So it's all good in the end. Yeah, this is on our side. I was working upstream on Substrate a little bit in here. There are 3 pull requests for the networking refactoring. They were merged, and there is a 4th one. And that might actually be useful for us. So initially there was just a C network crate in Substrate, which contained all of the networking implementation with peer-to-peer and everything. It also contained logic for the sync process and for light clients communication and warp sync and everything. And they wanted to split it. There is this long-standing issue, and they just took this and started working on it. So the 4th part has a C network common, which has some interfaces and data structures which are shared. It has light client part of it separately. It only depends on the common data structures. It has the sync part of it, including warp sync, which also only depends on the common part. And then there is a C service, which uses network and all of the other crates to actually like wire it together. So theoretically, we should be able to take this, wrap it with our own custom stuff, and then we can attach additional information to the block. Let's say we can have our proof of replication be compact, meaning not including the piece in it, not include 4 kilobytes in the header every time, and we can like attach it to the side of the block and just propagate it together, but not store in the history because we already have it as part of the history. So this is a massive pull request. I have no idea when they will get to actually review it, but hopefully in the coming days, weeks. And we'll see from there, from their feedback, what will be the next steps towards this networking refactoring. But it looks pretty good so far. I haven't seen much complaints from them on the previous pull requests. Yeah, this is from April last year. Yeah, also some other pull requests. I guess that's all on my side so far. Any questions about any of this? All right. For the next few days, 2 goals: preparation for incentivized testnet and voting. That will occupy a lot of my time. Probably not even on coding side, but like infrastructure, creating like VMs and endpoints and everything.
Have you been able to figure out if voting can be done as a runtime upgrade, or do you think it will be ready before?
I'm almost certain it will be possible. Not 100% sure that yet, but I'll try to make it work. We'll see. Okay, I think that will be all for today then. Right. Thanks everyone on YouTube for watching. We'll see you in next week, same time, same place.